All right, all right, all right. So I know what you're here for. This is 2433. Find the original array of prefix XOR. Okay. So this is a problem where it requires you to understand, the fundamentals of bitwise operations. Okay. And before we even read the problem, I'm seeing the term XOR, right? Find the original array of prefix XOR. So probably we got something to do with XORs here. Okay, so before I even read this problem, we're going to just kind of really quickly go over what an XOR operation is, what that looks like, and how it can be, leveraged. What are the fundamental rules that we can use when doing an XOR kind of problem. Okay, so like any other bitwise operation, right? We should start with the idea of having A and B, and then the output of doing this. Okay, so this is a bitwise operation, which means that it operates on each individual bit in something. If you don't understand what a bit is, right? A bit is just a 0 or 1, right? A binary representation of some number. Okay, now what we'll do is we'll exhaust all possible combinations, right? All possible things that could occur in between some bitwise operation. And then we're going to do A, and this symbol represents XOR. I guess I'll use this symbol here because that's what they use in the problem. But it's also common. So A XOR B, what does that equate to? An XOR operation is essentially when something evaluates to true or 1 when one or the other is true, but not both. Okay, so is one or the other true in this example? No, it's 0 and 0. So 0 XOR 0 is 0. 0 XOR 1 is one or the other true, but not both. Yeah, one of them is true, not both of them. Is one of them true, but not both of them? Yes. Is one of them true, but not both of them? No, because they're both true, right? So the idea of XOR is one can be true or the other can be true, but not both of them can be true. Okay. So this is the simple XOR table for A or B. Now, something to think about, operations to think about that we're going to use in this problem related to XORs is, some of the simple operations you can do and what they are equal to. Okay, so what happens when you XOR something like A with 0? What does that give you? Well, let's look at this table again. So if we had A XOR 0, what would that look like? So we had A and we had 0. All the options for 0 are 0, 0. All the options for A are A, 0. I mean, I'll do it again just so you can see the whole thing here, or just so the tables make sense, but I have repeated operations here. So what is A XOR 0? If A is 0, it stays 0. If A is 0, it stays 0. If A is 1, it stays 1. If A is 1, it stays 1. So from this operation, you can see that A or 0 XOR 0 is equal to A. Okay, so right, we have the first operation here, which is our table, but we'll note that A XOR 0 is equal to A. Okay. What about A XOR itself? What is A XOR A equal to? All right, well, let's write out the table again. So we have A being 0, A being 1. Right? What's the result of AND A with itself? Well, if you think about it, right, when A is 1, so they're both 1, so it becomes 0. If A is 0, then A is 0, so then they both become 0. So no matter what, it becomes 0, right? Because he's 0, 0, 0, 0, 1 or 1, XOR 1 XOR 1 is 0 because they can't both be true and 0. So any A modded with itself equals 0. All right, so these are kind of the two operations that we need in this problem. These two facts here, and we're going to use these to, massage and modify what is given in order to solve the problem. Okay, so this is just a very quick lesson. You should probably already understand what XOR operations are before you approach this problem, but I think it's good to just have a little bit of a background, right? So, how do we derive this, right? So we just looked at the table and we looked at the facts, right? What's the facts of an XOR of all combinations? And then we made some decisions about okay, what does that imply about certain XOR operations? And it turns out if you XOR A with nothing, you get itself. And if you XOR A with itself, you get nothing. Okay. And with that, let's go ahead and actually read the problem. Okay, so you're going to be given an array, integer array pref of size n. All right. It's so annoying with this Leetcode update that you can't, like, it doesn't find and return the array of size n that satisfies the certain condition, where pref of I equals array 0 XOR array 1 all the way up to array I. Okay, and that's what you're given. Note that this is the bitwise XOR operation. Okay, it can be proven that the answer is unique. Okay, so you're basically given an array. It's kind of confusing, the wording of this, but you're basically given an array where the following is true. Okay, so you're given an array where pref of I in this given array equals array at 0 XOR array at 1 XOR dot 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 all the way to array at I. All right. Now, what does that mean for certain examples? Well, that would be then that pref 0 equals array at 0. Pref 1 would equal array at 0 XOR array at 1. Pref 2 would equal array at 0 array at 1 array at 2, and so on and so forth. Okay, and what we need to do is we're given this pref array here, right? We're given this, and we need to determine from what's given, from this pref array given, what is the actual, we're trying to return this information, right? Which is, what is the actual array 0, right? We're trying to figure out what this array is. Array, and I don't know. All right, so we're trying to figure out what this actual array is here from the pref array. So it kind of makes sense, right? Because we're given this pref array and it has information in it, right? It actually has like details, right? It has like information about array 0 and array 1. It has all the information, it has everything in it, but it's kind of baked into it, right? So we need to somehow like extrapolate, right? We need to find what the actual values are and put them back into the array. Right, now I'm not even going to do the example because this is one of those problems where just based on the bitwise operations you can figure out what needs to be done. Okay, so let's try to reconstruct this array, just given the information generally here. And what I mean by that is like, okay, well, we're trying to figure out, well, what is first, like, what is array 0 going to be? Well, we know already that that's here, array 0 by itself. And so that's pref 0. So we can just put pref 0 here. Okay, what's array 1? Well, we have array 1 information here, but it's XOR'd with array 0, and we're given pref 1. All right, so we know this, we're looking for array 0, we know this information, and we know this information. Okay, but it's kind of like we're stuck here because it's like, well, how do I isolate array 1? And what you basically need to do is like bitwise algebra. Okay, and you can do bitwise algebra because we know some facts about operations that you can do. Okay, if I can apply an operation to one side, I can apply it to the other side, right? I mean, that's a legal mathematical idea, right? If you have the two sides of an equation, I can do things and apply stuff to make stuff happen, right? So what I'm going to do is I'm going to take this out. I'm going to put it over here so we can use these kind of stats here, these facts, and see if we can try to find something about this problem, okay? So what I'm saying here is I'm trying to figure out what array 1 is. I already know array 0 and I know pref 1, right? But I need to figure out how I can get array 1. Well, one legal thing I can do is if I XOR both sides by array 0, I get the following. Array 0, XOR, array 1, XOR, array 0. Is that on the page? No, it's not. All right. Okay. And then it doesn't really matter which way you XOR things, right? So I can switch these within the same, on the same side of the equation. So this is pref 1 array 0 equals array 0 XOR array 0. So I'm just switching array 1 and array 0. It doesn't change anything. Okay. Now, you'll notice here that I have this case, right? I have array 0 XOR array 0. So that's essentially A or A, right? Something multiplied XOR by itself is nothing, is 0. So if I go really fast here, I could have just copied it, but I did not. Equals 0 array 1. And then the other fact is A XOR 0 is A. So 0 XOR array 1 is just array 1. So that means that array 1 equals pref of 1 array 0. And these are both things that I know, right? So in this spot, I can just put pref of 0 XOR array 0. Right, and that's what will be in this second slot here. So that's what equates to this. Okay. Now what about array 2? So array 2, all right, this is not pref 0, this is pref 1. I was wondering what's going on here. Pref 1, right? Directly from this equation. So array 2, I'm not going to go through the whole thing again, right? But if I was to XOR both sides by array 0 XOR array 1, right? If I was to do that, then these two terms would delete, and I'd isolate array 2 on the side, and then on this side I'd have pref 2 XOR array 0 XOR array 1. Right? So, and those are things that we just found. So we've already found that. Now, one last, I guess, simplification we can make here is that, well, array 0, array 1, right? Like this information here, well, that's just this over here, which is just pref 1. Right? The same thing with pref 1. Pref 1 was array 0, array 1, but it's actually array 0, which is pref 0. So if you need to pause here and kind of like walk back what I'm doing, what I just said is basically, this is an array 0 here. This is simply put pref 0. And of course, this is, you know, the next one is pref 2 XOR array 0, array 1, but that's equivalent to pref 2 pref 1. Okay, so general case here is for any array I, the answer is pref of I mod pref of I minus 1. And just to quickly do a proof there, right? So pref of I equals array 0 mod array 1. What I say mod? XOR array 1, XOR array 2, XOR dot, 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 all the way up to array I. And then if I XOR that with pref of I minus 1, well, what's pref of I minus 1? That's XOR. We don't need the parentheses here. You get it. XOR array 0, array 1. A lot of calculations here to prove something. Dot, 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 all the way up to array I minus 1. Okay, so what term is left? Well, this term, array 0, gets eliminated here. This array 1 gets eliminated here. This array 2 gets eliminated, in here. This array I minus 1 gets eliminated here. So basically the only thing that's left after you kind of cancel all these out is array I. Okay. And that's essentially what, I showed here super messily and maybe a little bit less messy here. So basically that's just a proof that that's what is equivalent here. So all we have to do, right, to recreate our array is we just do this operation. Of course, array 0 equals pref 0 because there is no previous value. And then for each subsequent value, we just say array I equals pref of I XOR pref of I minus 1, right? And we're given that information, so we should be good. All right, so let's go ahead and just solve this. So we find the array, we'll create our new array. We'll do, there's so many ways to do this, and I don't. I'm just going to call it res, return res. Well, the first one is pref 0, we already said that. And then for the remainder, right, in range 1 to length of pref, array of I equals, but we'll just append it because this is the newest element, equals pref of I XOR pref of I minus 1. I was thinking about doing some kind of different ways of doing this, right? You could also create this array to start. There's always a million ways to do this. And then you would just say res of I equals pref of I and then, well, the previous value isn't that, so never mind. Think long, think wrong. All right. Oh, I still need, it's gonna be missing a value. All right, well, that loads. So what is the time and space of this? Time. Well, we have to look at all n values, right? We take the first value. So if n is the length of pref, right? We look at all n values and do a calculation, right? So we look at all n values, n minus 1, but then this first value. So look at all n values, do this constant operation. I guess this is like log of the largest number. But this is, there's the most 32 bits in any number provided. So this is always 32 operations, right? Because you have to do bitwise operations. You have to look at each individual bit. So, 32 operations, 32n is still n. For space, well, it's O of n technically because we have to create the array that we're returning, right? So we have to create an O of n array to return the n elements, but it's constant extra space, right? We don't use any extra space except for the space that's given, right? And there probably is a way to do this where you use the pref that's given and you like edit it and then return that, but that's kind of messy. You'd have to keep track of, I don't want to do that right now, but you could do that, right? Because all you need is the previous value and the current value. So as long as you kept two constants for the two previous values, and then you could just backfill like that. All right, that's it. Later, players.